Hi students, welcome to my channel Divyas Maths. Today we will discuss quadratic equations. If you are new to my channel, please do subscribe to my channel Divyas Maths and like, comment and share the videos with your friends. So let's get started. We will discuss about quadratic equation. So before discussing about quadratic equation, we will see what is quadratic polynomial. So we have learned in the polynomials chapter what is a quadratic polynomial, right? So the polynomial in which the highest power of a variable is 2, then it is said to be a quadratic polynomial. So let us take an example of a quadratic polynomial, that is x square plus x minus 2. So if you say this quadratic polynomial, the highest power of a variable is 2 here. So it is said to be a quadratic polynomial. And this expression is said to be quadratic polynomial because it is the combination of the constants and variables. Okay. Now see here, what is a quadratic equation? We are equating this quadratic polynomial to something. It is said to be a quadratic equation. Okay. We know that quadratic polynomial can be written as p of x. Okay. So if we are equating this quadratic polynomial to something, it is said to be a quadratic equation. Okay. So the general form of a quadratic equation is ax square plus bx plus c is equals to 0. Okay. Here ax square plus bx plus c, this is a quadratic polynomial and we are equating it to 0. Okay. So it is said to be a quadratic equation where a is called the coefficient of x square, b is called the coefficient of x and c is the constant term. Okay. So a, b and c are real numbers and a should not be equals to 0. A should not be equals to 0. So what happens if a is equals to 0? If a is 0, this whole term will be 0. Right? If the whole term is 0, you will remain with bx plus c is equals to 0. And this is a linear equation. Correct? So in this chapter, we will be discussing about quadratic equation. So a should not be equals to 0. Okay. Let us take few examples of a quadratic equation, which is x square plus x minus 2 is equals to 0 and x square minus 1 is equals to 5. So this is a quadratic equation, right? Because the highest power of a variable is 2 and it is equals to 0, right? This is in the form of p of x is equals to 0, right? So this is a quadratic equation. And what about the next equation? That is x square minus 1 is equals to 5. Is this a quadratic equation? Now see here, we need to get it in the form of p of x is equals to 0. If you can get any equation or if you can rearrange any equation in the form of p of x is equals to 0, then it is a quadratic equation. Okay. Now see here, we can get this 5 to LHS, right? So you will have x square minus 1 minus 5. In the RHS, you will have 0, right? So this equation will become x square minus 6 is equals to 0. This equation is a quadratic equation, right? This is in the form of p of x is equals to 0. Okay. So let us take few more example to understand what is a quadratic equation. Okay. So a quadratic equation which is in the form of p of x is equals to 0, it is said to be a quadratic equation. Okay, the general form is ax square plus bx plus c is equals to 0. So the powers should be in the descending order. Okay, it is ax square bx to the power 1 and c, here you have x power 0. Okay, so always remember the degrees of the term should be in the descending order. So if you see this equation, in the first term the highest power of a variable is 2 here and the whole equation is equals to 0. So this equation is said to be a quadratic equation. Okay, so when you compare this equation with the general form, you will get a is equals to 2. This is a and x square, right? You will get a is equals to 2. B is equals to, when you do not have anything, this is 1. Okay, B is equals to 1 and C is equals to, you will take the whole term which is minus 300. Okay, clear? In the next equation, so the first term which is 2x square, the highest power of the term is 2 and it is equals to 0. So this equation is said to be a quadratic equation because it is in the form of p of x is equals to 0. And the general form is ax square plus bx plus c is equals to 0. When you are comparing it with the general form, you will get a is equals to 2, b is equals to minus 3 and c which is 1. Okay, clear? Now let us see the next equation. So see here, if you see this equation, the equation is jumbled, right? First you have 4x term and then next you have minus 3x square and then next you have plus 2 term. Now in this case you need to rearrange the equation so that you will get in the form of p of x is equals to 0. So that you will get the first term as ax square plus the second term you will get it as bx and the third term should be constant which is equals to 0. Okay, so what is the first term which is ax square? So the first term in this equation will be minus 3x square. Okay, so write it here, minus 3x square, and the next term in the equation is plus bx. Okay, so here you will get plus 4x. And the last term is constant. So take the constant term which is plus 2 is equals to 0. Okay, so always take a positive term for x square. Okay, so if you take minus common here, which becomes 3x square minus 4x minus 2 is equals to 0. Okay, so then next we will send minus to RHS. So the equation becomes 3x square minus 4x minus 2 is equals to 0. Okay, so this is the equation which we required. Okay, from here, now let us compare it with the general form. You will get a is equals to 3, b is equals to minus 4 and c is equals to minus 2. Okay, clear? Now let us see the next example. 1 minus x square plus 300 is equals to 0. First let us check if this is a quadratic equation. So you have equals to 0 and the power of the variable is 2, right? So it is a quadratic equation. So let us rearrange the equation as p of x is equals to 0, where p of x is equals to ax square plus bx plus c is equals to 0. Okay, here ax square is your minus x square term, right? So write it here, minus x square. And do we have any bx term here? No, we do not have any x bx term, right? So we'll just leave it. And what is the constant term? We have 1 and we have 300. Okay, so take plus 301 is equals to 0. Okay, again take minus common, which is x square minus 301 is equals to 0. So you will get x square minus 301 is equals to 0. Okay, so this is our required quadratic equation. Now comparing it with the general form, you will get a is equals to 1 here, which is, this is 1, right? A is equals to 1 and you do not have any b term, so b is 0. And c is equal to, you will take the whole constant term, which is minus 301. Okay. Now see here in this example, so from this equation, that is x square minus 7x plus 10 is equals to 0, how will you find the value of x here? Okay, how will you find the value of x? So if you substitute a value in this equation, okay, in this equation, if it satisfies this equation, that value will be the solution of that equation, or it is said to be roots of that equations. When you substitute a values in this equation, if that value satisfies this equation, okay, if that value satisfies this equation, so then that value will be solution of the quadratic equation, or it is said to be roots of that quadratic equation. Okay, so see, for example, if you substitute x is equals to 2 here, if you substitute x is equals to 2 in this equation, this becomes 2 square minus 7 of 2 plus 10 is equals to 0. Then you will have 4 minus 14 plus 10 is equals to 0, which is 14 minus 14 is equals to 0. So we can say that this 2 is the solution for this quadratic equation, or it is the root of the quadratic equation. Okay, see, it is a quadratic equation and the degree, the power of the quadratic equation is 2, right? So we have 2 roots. So one root is 2. Let us see what is the other root. So let us substitute x is equals to 5. So let us take x is equals to 5 here. You will get 5 square minus 7 of 5 plus 10 is equals to 0. So 25 minus 35 plus 10 is equals to 0. 25 plus 10 is 35. 35 minus 35 is equals to 0, which is also satisfying this equation. So we will call 2 and 5 as the roots of the quadratic equation. Okay, they are called roots. Okay, so the quadratic equation has 2 roots. See, we have discussed the value of a variable for which the equation satisfies is called the solution or the roots of a quadratic equation. The quadratic equation has 2 roots, right? So we have seen this example, x square minus 7x plus 10 is equals to 0. It has got 2 roots, which are 2 and 5, right? We have a formula to find the roots of a quadratic equation. Okay, it is called as a quadratic formula. So this formula is x is equals to minus b plus or minus root of b square minus 4ac by 2a. So this formula was given by Sridharacharya. He is an Indian mathematician. So this formula is known as Sridharacharya's formula, or you can call it as quadratic formula. Okay. So in this formula, if you see, you have b square minus 4ac, right? You have this b square minus 4ac. So this b square minus 4ac is called discriminant. So discriminant is represented as capital D, or it is also represented as delta. Okay. So here b square minus 4ac can be replaced with d. Okay. So if you replace b square minus 4ac with d, the formula changes to x is equals to minus b plus or minus root of d by 2a. Okay. So if you see in this formula, you have plus or minus. So what is plus or minus? So you can take this formula two times. One is with plus sign and one is with minus sign. You can take the formula as x is equals to minus b plus root of b square minus 4ac by 2a, and next one is x is equals to minus b minus root of b square minus 4ac by 2a. Okay. So we know that this quadratic equation has two roots. Right? So how will the two roots be? What is the nature of that two roots? We will discuss about the nature of the roots of a quadratic equation. But what is the quadratic formula? X is equals to minus b plus or minus root of b square minus 4ac by 2a. Yes? Now see here, nature of the roots depend on this b square minus 4ac. Okay, so if b square minus 4ac is greater than 0, so see here, x is equals to minus b plus or minus root of b square minus 4ac by 2a. Okay, so if b square minus 4ac is greater than 0, if it is greater than 0, so you will get a positive integer, right? So see here, for example, if the whole thing is positive, okay, if this whole thing is a positive integer, for example, if we take b square minus 4ac as 5, 9 and 25, okay, for any of the values you can solve for x. If for any positive integer which is greater than 0, you will get real and distant roots. Okay, when you draw a graph for the quadratic equation, for b square minus 4ac is greater than 0, you will get a parabola like this. Okay, this is the graph for the d greater than 0. Now, the second case, which is b square minus 4ac is less than 0. What happens if this b square minus 4ac is less than 0? If b square minus 4ac is less than 0, it is a negative integers, right? You will get a negative numbers, right? See, if it is negative numbers, the root of minus 5 or root of minus 7, can you solve them? They are imaginary roots. Correct, they are imaginary, they are complex. So when b square minus 4ac is less than 0, you will get imaginary or no real roots. Okay. Now what happens if b square minus 4ac is equals to 0? Now see here, if this is equals to 0, if b square minus 4ac is equals to 0, okay, the whole term will be equals to 0. Right? So you will have only minus b by 2a. So they are real and they are equal roots. So in such cases, you will get real and equal roots. Okay? This is how the nature of the roots of a quadratic equation looks on a graph. This is for discriminant greater than 0. This is for discriminant less than 0, and this is for discriminant which is equals to 0. Okay. Now let us see what is the relationship between the coefficients and roots of the quadratic equation. So we know the general form of a quadratic equation, that is ax square plus bx plus c is equals to 0, where a should not be equals to 0, right? So let us assume that alpha and beta are the roots of this quadratic equation. Then what will be the sum of the roots? So sum of the roots, that is alpha plus beta to minus b by a, which is in this equation a is coefficient of x square, b is coefficient of x, and c is the constant term. Okay. Now here minus b will be minus b is nothing but coefficient of x. Coefficient of x by a is coefficient of x square. Let us see product of roots. Product of roots alpha beta. Alpha beta will be c by a. C is the constant term, and a is the coefficient of x square. Okay, and here we also have difference of roots. Okay, difference of roots, that is alpha minus beta. Alpha minus beta is root of discriminant, which is b square minus 4ac by a. Okay, and see here, and this quadratic equation can always be expressed in terms of sum and product of the roots. Okay, that is x square minus sum of roots into x plus product of roots. So this can also be written as x square minus sum of roots are nothing but alpha plus beta into x plus alpha beta. Okay. So let us just recap. So if we assume alpha and beta are the roots of a quadratic equation, x square plus bx plus c is equals to 0, then sum of the roots alpha plus beta will be minus b by a. And product of the roots alpha beta will be c by a. And difference of the roots alpha minus beta will be root discriminant by a. Okay, and the quadratic equation can always be expressed in terms of sum and product of the roots, which is x square minus alpha plus beta into x plus alpha beta. Okay, and these are the factors. Okay, now we will discuss what are the methods to solve a quadratic equation. Okay, so see one method which is very familiar, that is factorization method. Okay, by splitting the middle term we will solve the factorization method. Okay, so in this chapter we will also learn completing the square method to solve the quadratic equations, and we will also use quadratic formula is given by Sridharacharya, and it is known as Sridharacharya's method. Okay, and what is the quadratic formula? X is equals to minus b plus or minus root of b square minus 4ac by 2a. So we will use this formula to solve this quadratic equation formula method. Okay. Now first let us solve factorization method using splitting the middle term. So we have taken the example x square minus 6x plus 5 is equals to 0. So this is a quadratic equation. We need to split the middle term, which is minus 6x. So to split the middle term, the first step we will multiply coefficient of x square and the constant term. Okay, so if you compare it with the standard form, which is this is a and this is c. So you will multiply a and c. A is nothing but coefficient of x square and c is the constant term. So here, which is 1 into 5 is 5. Okay. The next step is you will find all the possible factors of 5. In this case, you will have 5 and 1. Right? Now, if you multiply them, okay, if you multiply them, you need to get 5. And if you add them, you need to get the minus 6, which is your middle term. Okay, this is minus 6, which is the middle term. Okay, so what will be the combinations? So if you multiply, you need to get plus 5, right? So if we can take minus 5 and minus 1, if you multiply them, minus into minus is plus. If you multiply, you will get plus 5, and if you add them, you will get minus 6. Okay. Now let us split the middle term. X square minus 5x minus x plus 5 is equals to 0. Okay. Now from the first two terms, if I take x common, you will have x minus 5. And from the next two terms, if I take minus 1 common, you will have x minus 5 is equals to 0. So x minus 5 and x minus 5 is common, and x minus 1 is remaining, is equals to 0. Now x minus 5 is equals to 0 and x minus 1 is equals to 0. If I send this minus 5 to RHS, you will have x is equals to 5, and if I send minus 1 to RHS, you will get x is equals to 1. So the roots will be x is equals to 1 and 5. So these are the roots of this quadratic equation. Okay. So this is how you will solve the factorization method. And next we will solve the same equation for the completing the square method. If you want to solve this method, you need to get this equation in the form of any identities such as a plus b whole square is equals to a square plus 2ab plus b square, or a minus b whole square, that is a square minus 2ab plus b square, or a square minus b square is equals to a plus b into a minus b. Okay, if you can arrange this equation into any of the identities, you can easily find the roots of this equation. So let us try to solve this equation. Now see here, x square minus, so we need to get in the form of a plus b whole square or a minus b whole square or a square minus b square. Okay, so if we want to get in any of the forms, then we need to rearrange this equation as a square plus 2ab plus b square or a square minus 2ab plus b square. Okay, so if you see here, we have a minus sign. So let us try to rearrange in this identity so that we can get a minus b whole square. Okay, so see, 6x can be written as, this is the middle term, which is 2ab. Okay, so I can take 6x as 2 into x into 3, right? 2ab, this is a square. Okay, this is a square, right? So when a is equals to x, I can take 2 into x into 3. Okay, now see here, 2ab, right? 2ab is nothing but 2 into x into 3. Here we can take b as 3, right? If I want to get this equation of this form, that is a square minus 2ab plus b square, I need to get plus b square, right? So let us add plus 3 square. If we are adding anything, we need to minus it, right? Minus 3 square. So the equation does not change. Plus 5 is equals to 0. Now if you see this is in the form of x minus 3 whole square, right? that is x square minus 2 into a into b plus b square, that is 3 square. Okay. And we have left with minus 3 square is 9 plus 5 is equals to 0. So you will have x minus 3 whole square is equal, I'm just sending this minus 9 plus 5 to RHS, which becomes 4. Okay. Now we have this x minus 3 whole square, which is in the form of a minus b whole square. Right. Now let us take square root on both sides. Square root on both sides. Okay. If you take square root on both sides, you will get root of x minus 3 whole square is equals to root 4. Okay. Root and square will get cancelled. You will have x minus 3 is equals to root 4 is nothing but plus or minus 2. Okay. Now let us take, now x minus 3 is equals to 2. We will take plus 2 as one combination and minus 2 as other combination. That is x minus 3 is equals to minus 2. Now let us send this minus 3 to RHS. You will get x is equals to 5. And let us send this minus 3 to RHS. You will get x is equals to 1. So you will get the roots as 1 and 5. So we have got the same roots as the factorization method. Right? So only the method changes, but you will get the same roots. Okay? This is the method 1. We can solve this by two methods. Okay, we can solve this completing the square root by two methods. You can solve them by any method you feel is comfortable to you. Okay, let us take other example and solve it by method 2. See, I have taken a different equation, that is x square plus x minus 20 is equals to 0. Okay, that is x square plus x minus 20 is equals to 0. Right? Now see, let us take first two terms same, x square plus x. Okay, and the third term, which is minus 20, we will take it as plus k is equals to, okay, we will take this minus 20 as k is equals to, we will take the identity x plus a square. Okay, now see here, this is same, x square plus x plus k is equals to, that is, I'm just writing this identity, which is x square plus 2xa plus a square. Now we will compare these both. Comparing both the sides. X square and x square is same. Now see here the second term, which is x, and here you have 2x and a. Okay, now let us compare it. You will get x is equals to 2xa. So x and x will get cancelled. So you will have 1 is equals to 2a. If you want to find the value of a, you will get 1 by 2. Now we will compare the next term, which is k. K is equals to a square. Right? What is the value of a? K is equals to, what is the value of a? Which is 1 by 2. So 1 by 2 whole square. So you will get k is equals to 1 by 4. Okay, now we have got a is equals to 1 by 2 and k is equals to 1 by 4. Now see here, now let us write the equation, that is x square plus x plus k. So x square plus x, and what is the k value? K value is 1 by 4 plus 1 by 4. So in this equation, if you are adding something, then you need to subtract it. So in the original equation, you have minus 20. So take minus 20 is equals to 0. Okay, clear? So see here once again, I have just taken here x square plus x, and we have got the k value as 1 by 4. But in this equation, in the original equation, we do not have any k value, right? So if you are taking any value, we need to subtract it. So we will subtract 1 by 4. Then we will take minus 20 is equals to 0. Okay. If you see till here, x square plus x plus 1 by 4. Okay. If you see till here, do you see any identity? Do you see any type of an identity? You can see the identity as a plus b whole square is equals to a square plus 2ab plus b square. Right? This is x square. So I can take it as x plus 1 by 4 is nothing but the b square. Right? 1 by 2 square is b square. Okay, 1 by 2 square is 1 by 4. So I can take it as 1 by 2. So I can take it as x plus 1 by 2 whole square. Now see here, if you take x plus 1 by 2 whole square, you will get x square plus 2 into x into 1 by 2. 2 will get cancelled. You will have x plus 1 by 2 square is 1 by 4. So we have expressed x square plus x plus 1 by 4 as x plus 1 by 2 whole square. And we have left with 1 by 4 minus 1 by 4 minus 20 is equals to 0. Okay. Now see here, x plus 1 by 2 whole square. If I take minus common, you will have 1 by 4 plus 20 by 1. See, if you solve it, you will get 1 by 4 plus 20 by 1, which is LCM is 4. You will have 1 plus 80. Okay, you will have 1 plus 80 by 4, which is x plus 1 by 2 square minus 1 plus 80 by 4 is equals to 0, which is x plus 1 by 2 whole square is equals to, I'm just sending this to RHS, you will have 81 by 4. Okay. Now again I'm taking square root on both sides. Square root on both sides. If you take square root on both sides, you will see root and square will get cancelled. Okay. You will have x plus 1 by 2 is equals to, this will be root 81 by 4, right? So this will be root 81 by 4, which is plus or minus 9 by 2. So you can solve for x plus 1 by 2 is equals to 9 by 2 and x plus 1 by 2 is equals to minus 9 by 2. Okay. Once you solve them, you will get x is equals to 4 and x is equals to 5. Okay. So these are the roots of this quadratic equation. Okay. So these are the two methods. You can follow any method which is easy for you. Clear? I will be taking many examples to solve this method as well. Okay. Now let us go with the third method, which is quadratic equation formula. What is the quadratic formula? Quadratic formula is x is equals to minus b plus or minus root of b square minus 4ac by 2a. Okay. So using this formula, we will be finding the value of x. Okay. So comparing this equation with the general form, you will get a is equals to 1. Here you do not have anything, it is 1, right? So a equals to 1, b is equals to minus 6 and c is equals to 5. Okay. So what is the general form? Ax square plus bx plus c is equals to 0. Now let us substitute in this. What is the b value? B value is minus 6. So minus of minus 6 plus or minus root of b square is minus 6 whole square minus 4 into a is 1 into c is 5 by 2 into a is 1. Okay. So, which is minus of minuses plus, you will get 6 plus or minus root of 6 square is 36. 36 minus 4 5s are 20. 20 by 2. Okay. So, which is 6 plus or minus root of 16 by 2. So, you will get x is equals to 6 plus or minus root 16 is 4 by 2. Okay. Now, let us take x is equals to, we have two combinations, right? Plus and minus. So, you need to take this 2 times. That is 6 plus 4 by 2 as one combination, and x is equals to 6 minus 4 by 2 as other combination. Okay. Which is x is equals to 10 by 2. You will get 5, and x is equals to 2 by 2, which is 1. So, we have got the roots as 1 and 5. Okay. So, if you see any of the methods, that is quadratic formula method or completing the square method or factorization method, you will get the same roots, but the methods are different. Okay. So, if you have a simple equation, you can solve it using factorization method. But if you have a complex equation, okay, you can use completing the square method, or you can use quadratic formula method to find the roots of the quadratic equation. Okay. And I will be solving many more examples using these 3 methods in my coming videos, and also I will be solving word problems from the exercises. If you have any doubts regarding the quadratic equation, let me know in the comment section below and I will respond to them. See you in the next video. Take care. Bye.